We're going to solve one last separable differential equation. I have dy dx is equal to x to the fourth times y minus 2 d, and I need y's on one side, x is on the other side. My first step here, you can see I've divided through by dx on both sides. No, multiplied through by dx on both sides. That leaves me with dy equals x to the fourth times y minus 2 times dx. Notice that your only operations available to you when you're separating the variables in a separable differential equation are multiplication and division. So here when I divide both sides, I have to divide by a factor. The factor that contains y is y minus 2. So my first step here, dy over y minus 2 is equal to x to the fourth dx. Now my variables are separated, and I can integrate both sides. Some people get confused when they first get started with separable differential equations and think maybe they're supposed to add 2 to both sides. The only operations available to you to separate the variables are multiplication and division. So make sure you're doing one or the other, or a combination. So this is where I was when I left off. I'm going to integrate both sides as my next step. So I'll slap an integral on. And then this next part, the left-hand side, if you use a u substitution, that's totally fine. If you get to the place where you decide you don't need a u substitution anymore, that's fine too. Notice if I let u equal y minus 2, then du happens to equal 1 dy. So the substitution is not complicated, and now maybe it's a little bit easier to see. That's going to be the integral of du over u, which we know, we've been practicing that one a lot lately. It's going to be the natural log of u on the left-hand side, and x to the fifth plus a constant on the right-hand side. But u is just y minus 2, so that's what I'm going to have. The natural log of y minus 2 on the left-hand side is equal to x to the fifth plus x to the 5 over 5 plus c on the right-hand side. So again, I've got 2 big steps left. I need to get y by itself. I need to figure out what c is. So I'm going to leave those guys there. So the natural log of the absolute value of y minus 2 on the left, x to the fifth over 5 plus a constant on the right. I'm trying to isolate y. The thing I have to undo first is that natural log, and I do that by exponentiating both sides. So that's where I make both sides of that equation exponents on a base of e. So the e to the natural log of cancels each other out. So I get the absolute value of y minus 2 on the left is equal to, here on the right hand side I have e to the x over 5 plus x to the fifth over 5 plus a constant. It's the same as saying e to the 1/5 x to the fifth times e to the c. So I've just rewritten that right hand side to show that I'm doing that. The next thing that I'm going to do, I'm going to have to undo those absolute value bars. We said we do that with a plus or minus sign. Oops, which much? So that's what I have here. Y minus 2 is equal to positive or negative e to the c times e to the x to the fifth over 5. Now this whole mess here, a positive or negative 2.71828 raised to some exponent that's a constant. That is just some other constant, which you will find typically referred to as a. It's not required that you make this substitution, but I want you to know what you see when you see it in books. So I'm going to write y minus 2 is equal to a times e to the x to the fifth over 5. And I think now is the time that's easiest on this problem to figure out c. There's plenty of other ways to do it. But now I'm going to stop and I'm going to take this equation that I had and I'm going to plug in my initial condition. My initial condition was that y is equal to 0 when x equals 0. So I'm going to replace the y with 0. So 0 minus 2 is equal to a times e to the x to the 5th over 5 when x is 0 is just 0. And e to the 0 is just 1. So when I solve this equation for a, I get that a is equal to -2. I'll keep the red. I'm going to take this back into my equation that I had a moment ago. So I'm going to replace the a with a -2. Y minus 2 is equal to -2 times e to the x to the 5th over 5. And now just one step left, and that's to isolate y. I'm going to add the 2 to both sides. So it's y is equal to 2 minus 2 times e to the x to the 5th over 5. There's no domain constraint here. Notice that I can use any real number as an exponent. So I can use any real number as an x to the 5th over 5 exponent without making discontinuities in my graph. So this is my final answer. Recall that I suggested you come through at the end here and check if this is my final answer. I should be able to plug in 0 for y to get and have x be 0. 2 minus 2 times e to the 0 is 0 equal to 2 minus 2 times e to the 0 is 2 times 1. Is 0 equal to 2 minus 2? That does check out. So there's my final answer.